Hi dear students, in this video I am going to explain parallel vectors and linear combination of the vectors, and here in which condition we are trying to understand the two vectors are parallel. If you multiply one vector by scalar, and then you will get the parallel vector to this one, which means that here also it's written if u and v they are parallel to each other, u should be equal to c times v1, scalar times v vector, not v1, sorry. And then if you remember the equality of the vectors, here u1, u2, the components of the u, and c times v, it should be equal to c1 times v1, and comma c times v2. So these two, they are going to be equal to each other. These two, they are going to be equal to each other from the equality, and these two, they are going to be equal to each other from the equality of the vectors. So here basically if u1 is equal to c times v1, then u1 is equal to c times v1. We are understanding that u1 over v1, it should be equal to c. It has to be, here this should be 1. It is a mistake of the book. So if this is v1, then then it's same for the u2 over v2, it should be equal to 0. Then in this condition they are going to be parallel. Here two vectors are given and it's asking to us show the vectors are parallel. What we are going to do, we are going to divide u1 over v1. Here the condition, it is equal to u1 over v1. It should be equal to u2 over v2. Are they equal to each other? Let's see. u1 over v1, it's equal to 2 over 1, and the other one, it's equal to 1 over 2. Here this is equal to, the first one is equal to 2, second one 1 times 2 over 1 it has to be. I can easily explain like this. As you know, a over b over c, it's equal to a times c over b normally, or a times c over b, then ac over b, which is equal to, here 2 is equal to 2 it becomes, which means that here the c value also it becomes 2. Okay, so these two vectors are parallel, so parallel vectors. Okay, find the relation between x and y. Find the relation between x and y here with respect to what it is asking. Find the relation between x and y if CD is parallel to AB. If CD is parallel to, these are the second points, so I mean the terminal points, and these are the initial points, so always we are going to subtract from initial two parallel points. So we are going to do like this here. And CD, it should be, I'm writing the first CD vector, CD it should be equal to D is x minus 5, and y it should be y minus 4, which is equal to y plus 4. It's going to be, this is CD vector. And what is the position vector of AB? AB it should be equal to 2 minus 3, and 3 minus 1, which is AB. We can write vector AB, we can write like this. AB is equal to minus 1 and 4. Here it's going to be equal to x minus 5 and y plus 4. This is for the CD vector. So if they are parallel to each other, CD, the components, let's say x minus 5 over minus 1, it should be equal to y plus 4 over 4 it should be. This is the condition. So we are going to find the relation between them. We are going to multiply by multiplying here, cross multiplication. 4 times x minus 5, it's going to be 4 times x minus 5, and on this side it's going to be equal to minus 1 times, minus 1 times y plus 4. Here 4x minus 20 is equal to minus y minus 4, it's going to be. And if you send y to this side to make it positive, because we are finding the relation between them, and x to this side, y is going to be equal to here minus 4x plus 20 minus 4, so y is equal to minus 4x plus 16, it's going to be. So this is the relation between x and y. Okay, let's continue with the linear combination. Here, any vector in the plane by using these colors can be written as the linear combination of the vectors. So here it says w vector in the question. Find the vector w if w is equal to 2 times u minus 3 times v. So w vector becomes the linear combination of the u and v. Here these colors are given 2 and minus 3. These are like C1 and C2 here. This is C1, it becomes, and this is C2. And you know, after this part, what we are going to do, we already solved this kind of questions in the previous videos. 2 times u means 2 times 5 and minus 2. And here minus 3 times 1 and 3 it has to be. So this is going to be like this. 2 times 5 is equal to 10, and 2 times minus 2 is equal to minus 4. Here you can leave the minus outside, or you can, if you send minus outside, then you should multiply by 3, but I'm going to keep the minus outside, so it's going to be equal to minus 3 times 1, it's equal to 3, 3 times 3, it's equal to 9. So this is the last part. W is equal to 10 minus 3 minus 4 minus 9, which is equal to W is equal to 7 and minus 13 it's going to be. So W is written as the linear combination of these two vectors. Okay, now this time we are going to solve v is equal to linear combination of two vectors like u1 and u2, which means v is equal to c1 times u1 plus c2 times u2 it should be. And we are going to find the c1 and c2 here, and v is equal to 12 and 5 is equal to c1 is equal to, we don't know, we are trying to write c1 and c2. u1 it should be equal to 2 and 1, and plus c2 is equal to, we don't know again, c2 it is not given, and we are going to find their values. And then here it's going to be equal to 3 and 2, because u2 is equal to 3 and 2. So you know, by multiplying the by scalar means 2 times c1 plus 2 times c1 and c1, this is going to be here c1 times 1 I'm talking about, then plus 3 times c2 and plus, not plus, again I made a mistake, and 2 times c2 it has to be here, and this is equal to 12 and 5. Here we are going to get, first I'm going to say these are equal to 2c1 plus 3c2, I'm adding this 2, and then here c1 is equal to c1 plus 2, c1 plus 2c2 it's going to be. Okay, then they are equal to 12 and 5. which means that 12 is equal to 2c1 plus 3c2. It should be equal to 12. They are equal to each other. And c1 plus 2c2, it should be equal to 5. So these are, system of equation. To solve the system of equation, I'm going to write downward here 2c1 plus 3c2, 12, and c1 plus 2c2 is equal to 5. I'm going to use elimination method. I'm going to multiply the c1 by 1 and this one I'm not going to multiply, and I'm going to multiply the second one by -2 to eliminate the c1s, and times -2, which is equal to 2c1 plus 3c2, since it is equal to 12, minus 2c1 minus 4c2 is equal to minus 10. It has to be. If you add them side by side, here these two, they are going to be eliminated, and minus 4c2 plus 3c2, it's going to be equal to minus c2, and when you add 10 plus minus 10, it should be equal to 2. So c2 is equal to minus 2, it's going to be. Then if c1 plus 2c2 is equal to 5, and c1 plus 2 times minus 2 is equal to 5, then c1 is equal to 5, and this is going to be minus 4, so 5 plus 4, it's going to be, and c1 is going to be equal to 9. So we wrote the V as linear combination of two vectors here, and we found that c1 and c2, they are equal to 9 and minus 2. Okay, and this is the last exercise. We are going to write now the vector x linear combination of these three vectors, and here we are going to use the same logic, like x is equal to c1 times u and plus c2 times, not plus, yes, plus c2 times v, and plus c3 times w vectors. These are all vectors. We are going to use this one. So let's do here this one. Let's multiply. X is equal to 19 and 13 is equal to c1 times u. It's going to, I'm going to shorten the things. So c1 times u is equal to 2c1 comma minus 3c1. It's going to be, and if you multiply c2 by v, it's going to be equal to c2 and 2c2. And if you multiply the c3 by w, it's going to be here 5c3 and 4c3. It's going to be, which means that 19 is equal to, 19 and 13 is equal to, here 2c1 plus c2 plus 5c3, 2c1 plus c2 plus 5c3, and comma minus 3c1 plus 2c2 plus 4c3. It's going to be. From this one we will get these two equations. 19 is equal to 2c1 plus c2 plus 5c3, c3 here, 5c3, and the second one, 13 is equal to, this is 19, 13 is equal to minus 3c3, 3c1 plus 2c2 plus 4c3, it's going to be. Okay, now we have three unknown and two equations. It is not possible to solve these equations like this. So we are going to write the C1 or C2 in terms of others. So I'm going to leave the C2 alone here. C2 is equal to 19 minus 2C1 plus, minus 5 C3 it's going to be. So we are going to replace this one in the second one. 13 is equal to minus 3 times C1 plus 2 times 19 minus 2C1 and minus 5 C3 plus 4 C3 it's going to be. Then here it's going to be equal to 13 is equal to minus 3C1 plus 38 and minus 4 C1 and minus 10 C3 plus 4 C3 it's going to be this 4 C3, and then we can collect the terms together, like 13 minus 38 is equal to minus 3C1 minus 4C1, it's going to be equal to minus 7C1, and here it's going to be equal to minus 4C1, pardon, minus 10C3 and 4C3, it's going to be equal to minus 6C3 it has to be. So minus 25 is equal to minus 7C1 plus minus 7 minus 6C3, or 25 is equal to, if I multiply by minus 1, 25 is equal to 7C1 plus 6C3. Here I have to find some values that satisfies this equation. If I find this one here, like if I choose C1 is equal to, I'm looking for integer solutions. If I choose one value for C1, I can find C3, then I can find C2 also. Here there's no other solution method here, so I'm going to choose one C1 value, like this is 1. Then here 25 minus 7 is equal to 7 times 1, minus 7 is equal to 6C3, so C3 is equal to 18 is equal to 6C3, so C3 is equal to 3 it's going to be. Then we are returning to this one here. If C2 is equal to 19 minus 2 times C1, I have chosen 1, and when I choose 1, I found C3 is 3 minus 5 times 3. C2 is equal to 19 minus 2 minus 15. C2 is equal to, it's going to be equal to 3 here. 19 minus 2, 17 minus 15 is equal to 2. So C1 is equal to 1, C2 is equal to 2, and C3 is equal to 3 is one of the linear combination. One of the linear combination I am telling because there are infinitely many solutions for this question. This is the end of the video.